So in 422, we have the ancient Indian square roots, right? The Bakshali manuscript, ancient mathematical work written on birch bark, appears in a 10th century copy of an even earlier work. The original manuscript was probably written during 200 to 400 CE, the Common Era. The manuscript gives a formula to estimate square roots. All right, so kind of get that from the notation that's used there, and really just a translation. All right, so if you see those particular symbols, that would correspond with a particular root. All right, so the formula for the square root of n. Square root of n is equal to the square root of a squared plus h. All right, so some familiarity based off of what we were just doing, but previous video. A squared is the greatest perfect square less than n, and h is given by n minus the a squared. So we're talking about relative distances again. All right. This one gives us a little bit of or a lot of a more complicated formula, but it also it gives us a higher degree of accuracy. Right? But you can see it's a lot to behold. Right? But the idea is that if you follow the formula, you'll be good to go. All right. So find the first thing you're looking for is the a squared value, which is going to be the perfect square value that's less than whatever the number is. So my a squared is going to be equal to 36. All right, just going back, I'll kind of steal some work from the previous video. The perfect square value is 1, 4, 9, 16, 25, 36, 49. The target number here is 41. The largest perfect square less than 41 is 36. All right, the n value, they told us 41, because that's what we're looking to find. That's this number here. So we calculate the h, which is going to be 41 minus 36, which is 5. All right. Then we can start setting up our formula. All right. Actually, just so I can reference it side by side, I'll do it up here. That's going to be, so the square root, I'll write that first step here, because we're looking for the square root of n. So square root of 41 is equal to the square root of 36 plus 5, and that's going to be approximately equal to 6, right? So if a squared is 36 and a is equal to 6, plus 5 over 2 times 6. And that right there would give you a reasonable approximation. But if we go further, and I'll kind of rewrite the next step as we go. 6 plus 5 over 12 minus 5 over, I'll write this as 5 over 12 now because 5 over 2a, 2 times 6 is 12, over 2 times 6 plus, again, a 5 over 12. So that's going to give me 25 over 144. I'm going to compute this. All right, again, it's 6 plus 5 over 12. 6 is really, if I'm doing it as a value over 12, 72 over 12. So 77 over 12. 154 over 12. I'm probably trying to do way too much mental math here, so I'm just going to give that a quick double check. Probably find out that I'm horribly wrong. 2 times, if I simplify it, it would end up being the same thing. Let me just double check that, make sure I'm not lying. Yeah, same thing. Okay, so I don't feel terrible about that. All right, so 6 plus 5 over 12. When you divide fractions, you do a little keep, change, flip action. So keep that the way it is. change from the division to multiplication and then flip, so I'll use some parentheses here. All right, and then I can simplify. Feel free to use a calculator. Sometimes I can't resist the urge to try to do some mental math or calculation. That being said, I'm probably going to a calculator now because not easily going to be able to simplify the rest of the way. I mean, I could multiply the 154 times 12, which is going to be 1540 plus 308. So 1848, I don't know. So 12 times 154, 1848. Okay. So then 25 up top. So we're looking at 6 plus 5 over 12 minus 25 over 1848. And then at this point, I would go decimal form. Yeah, I don't see a better way. Oops. All right, so we're looking at about 6.403. What do they say? To round anywhere? Just approximate it. 16.403. Okay. 4031. They went the extra decimal, which I guess makes a little bit of sense because even though they didn't say it here in the last set of problems, they went 4 decimals. They kind of threw it in here at the end. Here at the end, but all good. The one little tip there, we tend to want to stay either with all decimal values, so write out the entire, you see like all this crazy decimal stuff here, or just leave it in fraction form. These calculators these days, they can handle fractions pretty well. So and they're not as burdensome as they used to be. So you can probably convince yourself that it's not anything too crazy. A little bit more calculation here. Obviously, the bigger the numbers get, the more crazy the calculations will be, but it's still fairly manageable. Referencing the formula always going to be important because I mean this. Sorry, let me just grab this here. This is a doozy. I think I wanted to do a screenshot actually. Huh. Okay. Yeah, maybe I did it the right way. I don't know. We'll see in a second, I guess. I'll just paste it down here so I have it. Yep. So in this case, I went a little too far. 5 decimal places now. So radical 11. So we're looking for at radical 11, the perfect square value that's just less than 11 would be 9. All right. So largest perfect square value that's below the 11. So we're looking at 9 plus 2, which we could think of as 3 squared plus 2, which makes the a value 3, the h value 2, over 2a. So if the a value is 3, then 2 times 3 is going to be 6, which we could write as 1/3. So we'll do that. So equals 3 plus 1/3. So minus, I'll put in the 1/3 here. 2 times 3 plus 1/3. All right, so minus, and we'll do keep change flip again. This is going to be 1/9 times. So here, 3 and 1/3 is the same as 10/3. All right, so you could do it this way if you want. Oops, well, maybe not precisely that way, but 10 thirds. You could also use that old trick, multiply and then add. 3 times 3 is 9, plus 1 is 10. Little old elementary school trick. If they still teach it, who knows? But that's going to end up being, when I multiply by 2, 20 over 3. So keep, change, flip, 3 over 20. 3 goes into 9 3 times. So 3 plus 1 over 3 minus 1 over 60. All right, so that's going to be, if I get a common denominator, it's going to be 180 over 60 minus 1 over 60, 179 over 60. So that's a, actually, that doesn't even seem right. Over 60, it would be 20 over 60. Is that 20 over? Yeah, 20 over 60. So 19 over 60. So 3 plus 19 over 60. All right, I'm going to double check that, obviously. So 1 minus 1 over 60. Well, 1 third. Yeah, 19 over 60. So I can write it as a mixed number. When you add a whole number in a fraction, if the fraction is a proper fraction, then you could write it as a mixed number and leave it at that. But you could also write it in its approximate form of 3.3167. All right, 3.3167. If I square that, I should get something close to the target number 11, which I do have. Or I can go the other way, and I get what the actual decimal value is, which is pretty close. Right? Oh, directions. They did say go 5 decimal places. So I'll get that extra decimal place in there. All right, and that would be the ancient Indian square root technique. All right, and so the next video we'll get onto Babylonian square roots.